All right, this is the part 2 of the chapter 7.3. So let's get started with the next question. All right, so first of all, we have a tangent theta over 2. All right, so what you're going to do is just put the inverse tangent on both sides. Okay, so what we're going to have is we're going to have theta over 2 equals to inverse tangent of rad 3. Okay, so that pretty much just give you two different answers. So let's start with the blue one. Okay, because you have you know that tangent is y over x. Okay, so you have negative y over a negative value for x. That's going to give you positive rad 3. Okay, so you are going to have the first one, the first measure is theta over 2 equals to 240. Okay, another one is going to be the one for 60. So you're going to also say that theta over 2 equals to 60. Okay, so you're going to multiply by 2 on both sides, on both equations. Okay, so what that's going to give you is theta equals to 120, or you're going to have theta equals to 480. Okay, so we know that you can't have 480 as your answer because that's not between 0 and 360. So your answer is going to be just 120. We're going to rewrite that as in radians. So it's going to be 2 pi over 3. So that's going to be your answer. Okay, number 30. This one is going to be a little tricky. So first thing I want to do is just put the inverse on both sides. Okay, so that cancels out. Now you're going to have 2 theta equals to inverse tangent of negative 1 over 1. Okay, I like to place it in fractions. You can actually think of it as negative 1 over 1 or inverse tangent of 1 over negative 1. Okay, so for the 1 over negative 1, since we know that tangent is y over x, so let's start with this one. Okay, so negative 1, that means y equals negative 1. So that's the one with the blue. So I have to change my color. So this is basically going to give you two different measures. So you're going to have 2 theta equals to 315 or 675. You might be wondering how come I'm including 675. It's because later on I'm going to divide it by 2. So if I divide it by 365 by 2, it's going to be within the between 0 and 360. Okay, so you might be wondering again, how did I get 675? Is because I know that the first spin that gives me 315. If you do a second spin, you just add 360. Then you're gonna get 675. Okay. All right. So that's how I got these two measures. So what I'm gonna do is I'm just gonna go ahead and divide it by 2. Okay. But what I'm gonna do here is I'm actually going to write the 315 and 675 in radians. Okay, so 315 is 7 pi over 4, and then 675 is going to be 15 pi over 4. Okay, so what I'm going to do is I'm going to multiply by 1/2. Okay, so I'm going to get theta equals to 7 pi over 8. Another one is going to be 15 pi over 8. Okay, so let's go ahead and do the other one. So I just have to get rid of this for now because I need some space to operate. Okay, so now we're going to be working on with the one with the 135 and 495. So we know that 2 theta is equal to 135. So 135, I'm going to rewrite that as in radians. So 3 pi over 4, 495, I'm going to write that in radians is 11 pi over 4. Okay, in order to get the pi, theta by itself, you have to multiply by 2 on everything. So it's going to be 3 pi over 8. Another one's going to be 11 pi over 8. So you got 4 different measures. It's a crazy one. That's why I put a little mushroom on it. Okay, so let's go ahead and do the next one. Another mushroom. All right, so we're gonna do the inverse first. So inverse of cotangent. Okay, so this is gonna give me 2 theta over 3 equals to inverse cotangent of negative rad 3 over 1. Okay, so negative rad 3 over 1 gives you 2 different measures. Okay, so let's go ahead and start with the red one. So the red one is actually 150 degrees. Okay, so we can say that 2 theta over 3 is equal to 150 degrees. Okay, you're going to multiply by 3 over 2 on both sides. You're going to get theta equals to 225 degrees. Okay, so write that in radians. It's going to be 5 pi over 4. Okay, that will be your only answer, because if you look at the other one, this is 330 degrees. So you said 2 theta over 3 equals to 330 degrees. If you multiply by 3 halves, you're going to get theta equals to 495. Okay, 495 is not between 0 and 360. Okay, so that cannot be your answer. So your answer is going to be 5 pi over 4. Okay, so I'm just jumping around. So this time we're going to be working on number 60. First thing I want to do is I'm going to add 1 on both sides. So I'm going to get sine squared theta equals to 1. Next thing I want to do is square root on both sides. So that's why I can, that's how I'm going to isolate my sine theta. In this case, I'm actually going to get 2 different values. I'm going to get a positive, okay, a positive 1, and another one is going to be a negative 1. Okay, so for the one with the negative 1, since I have my blue on, it's going to be 270. Okay, I wrote the symbol wrong. It's theta. That was horrible. Okay, so this theta is going to give you 270. Okay, and another one is going to be theta equals to 90. Okay, so convert that to radians. This is going to be pi over 2. And then the other one is going to be theta equals to 3 pi over 2. Okay, so these are your answers. Okay, so now let's look at number 62. This time we're going to be talking about quadratic in form, because if you look at this, it does look like a quadratic equation. Okay, so what I'm going to show you is using a method. We know that cosine theta is basically x, right? So I'm going to sub in x to show you guys that this is going to look like a quadratic equation. Okay, so I'm going to rewrite that as 2x squared. We know that x is cosine theta plus x minus 1 equals to 0. Okay, in this case, you can just go ahead and factor it. So it's going to be 2x minus 1, x plus 1 equals to 0. Okay, due to the zero product property, you're going to set each one of the binomial equals to 0. So we're going to have 2x minus 1 equals to 0, x plus 1 equals to 0. Okay, you see that I purposely put the x away from the positive and negative. because I'm going to rewrite the x back to cosine theta. Okay, so I'm going to put 2 cosine theta minus 1. For this one, I'm going to put cosine theta plus 1 equals to 0. Now I'm just going to go ahead and solve it. Okay, so you're going to add 1 on both sides, and you're going to subtract 1 on this side. So you're going to have 2 cosine theta equals to 1. So cosine theta equals to 1/2. Okay. The other one is going to be cosine equals theta equals to -1. So for this cosine theta equals to -1 is going to be just the one I'm showing you here. So for that one, you're going to have theta equals to pi. So that's going to be one of your answers. I didn't show you guys this one, but I'm going to just draw it right here and show you. Okay, so 1/2. So 1/2, you can pretty much get 2 different scenarios. Okay, so which means that x equals to 1, radius equals to r. Well, what I'm saying, 2 equals to r. So you're going to get 2 different triangles in quadrant 1 and quadrant 4. Okay, the one in quadrant 1 is going to be 60 degrees. The one in quadrant 4 is going to be 300 degrees. Okay, so you can rewrite that as in radian. So theta equals to pi over 3 and 5 pi over 3. Okay, so that's going to be your answer. A little crazy, right? Okay, let's look at number 66. So this is another quadratic in form. So for this one, I want you guys to know the Pythagorean identity. So you know that since sine square theta plus cosine square theta equals to 1. So you can rewrite that by subtracting sine square theta on both sides. So you have cosine square theta equals to 1 minus sine square theta. Okay, so let's just go ahead and rewrite this as 1 minus sine square theta. Okay, let me get this, let me clear this out. I need more space to operate. Okay, so subtracting sine squared theta plus sine theta, okay, which equals to 0. So what you're going to do is that you're going to go ahead and combine everything. You're going to get, I'm going to have to squeeze this in. So you're going to get negative 2 sine theta square theta plus sine theta plus 1 equals to 0. Okay, what I'm going to do is I'm going to just multiply everything by -1, the whole entire equation by -1. What that does is that my leading coefficient is going to be 2 sine squared theta minus sine theta minus 1 equals to 0. Okay, it's just a lot easier for me to just handle it if it's the leading coefficient is positive. Okay, so you're going to go ahead and you can use the method I taught you earlier. You know that sine theta is basically y, so I'm going to sub in y to help you to see this more clearly. So I'm going to erase the sine squared theta and the sine theta. I'm going to put the y in there. Okay, so let's go ahead and factor this. So this is going to be 2y plus 1 multiplied by y minus 1. Okay, equals to 0. Okay, up to this point, you know that y is basically just your sine theta, right? So let's reverse by putting the the sine theta back into y. So it's going to rewrite this as 2 sine theta plus 1 times sine theta minus 1. Okay, so yeah, it's a little crazy here. You're going to have to set each one equals to 0. Okay, so I need more space to operate. I'm going to erase everything on top. Just know that I'm going to be using different color. Stay tuned. Okay, so we know that 2 sine theta plus 1 equals to 0. We also know that sine theta minus 1 equals to 0. So we're going to go ahead and subtract 1 on both sides. Okay, so we got 2 sine theta equals to negative 1. Sine theta equals to negative 1/2. Okay, another one, just going to add 1 on both sides. Okay, so you have sine theta equals to positive 1. Okay, so let's erase this. All right, so for the 1 with the sine theta equals to 1 is basically just theta equals to 90 degrees. Okay, so for that, get my purple out, theta equals to pi. Okay, now let's look at this tricky one. Okay, so this tricky one is going to give you, you know that sine theta is basically saying y over r, right? So that's saying negative 1 over 2, negative 1 over 2. So you're going to get two possible measures in quadrant 3 and 4. So you can identify that one of them is going to be 210, another one's going to be 330. So for the 210, you're going to write 7 pi over 6. For the 330, you're going to write 11 pi over 6. Okay, so those are also your answers. You got 3 different measures. Okay, so let's look at 68. So number 68, it looks crazy, but the craziest part is that you have to bring back one of the even or odd functions. Cosine, it's even function. Okay, so which means that you can rewrite that as positive cosine theta. Okay, so I'm going to rewrite the entire equation as 2 sine squared theta equals to 3, and then put parentheses, 1 minus cosine theta. Okay, so I'm going to distribute the 3. So I'm going to rewrite this as, I'm just going to erase it so I can save some space. 3 minus 3 cosine theta. Okay, so the next thing I want to do is I'm going to move these two terms to the left side. Okay, so I'm going to do is I'm going to subtract 3 on both sides. I'm going to add 3 cosine theta on both sides. Okay, so let's see how it goes. So I'm going to get 2 sine squared theta plus 3 cosine theta minus 3 equals to 0. Okay, so yep, so that's a little crazy right there. You guys, you can see that we got sine, we got cosine there. So let's bring back one of the Pythagorean identities. So we know that sine squared theta, you can rewrite that as 1 minus cosine squared theta. Okay, so if I rewrite that, I'm going to put a parentheses and the 2 right here, plus 3 cosine theta minus 3 equals to 0. Okay, so I'm going to distribute the 2. I'm going to have to erase stuff on top in order to write the rest. Use a different color. Okay, so that's distribution is going to give you 2 minus 2 cosine squared theta plus 3 cosine theta minus 3 equals to 0. Okay, wow. Okay, it's going, wow, this is crazy, right? I can't even rewrite them. Gosh. Okay, Now let's just combine all the like terms. Okay, so if you combine it, you know that 2 and -3, so 2 minus 3, that's going to give you a minus 1, that's going to give you a minus 1 in the end. Okay, and then it's going to be -2 cosine squared theta plus 3 cosine theta. Okay, writings are getting a little sloppy, so let me erase this. Okay, so I'm going to do is I'm going to multiply the whole entire equation by -1. You don't always have to do this. I just want to make my leading coefficient a positive 2 cosine squared theta minus 3 cosine theta, and then plus 1. Okay, so go ahead and understand that this is another quadratic in form. This time I'm not going to use substitution. Okay, no substitution. I'm just going to go ahead and factor it. So it's going to be 2 cosine theta minus 1 times cosine theta minus 1, which equals to 0. Okay, so I'm going to set this equal to 0, set that equal to 0. Now let me erase the top part. I'm going a little fast, so feel free to pause. Okay, so 2 cosine theta minus 1 equals to 0. Cosine theta right here minus 1 equals to 0. So what I'm going to do is I'm going to add 1 on both sides. Right now I'm just trying to find out what theta is. So it's going to be 2 cosine theta equals to positive 1, and you're going to divide it by 2. So cosine theta is going to equal to 1/2. Another one, cosine theta is going to equal to positive 1. So for the one with a positive 1, let me erase this. Pretty simple. It's going to be the one with 0 degree. Okay, so you can just go ahead and say theta equals to 0. It's going to be one of your answers. So for the cosine, theta equals to 1/2. Since this is x over r, so which means that your x is going to be 1, right? And you got 1 in quadrant 1, another one in quadrant 4. Okay, so your theta is going to be 60 and 300. Okay, so 60 you can write it as pi over 3. 300 you can write 5 pi over 3 in radians. Okay, so that's 68. Let's look at number 70. So this one is actually going to be an odd function. So you have to rewrite this as negative sine theta. Okay, so let's rewrite everything else. So this is cosine theta minus the negative sine theta equals to 0. Okay, so in this case, you're going to have cosine theta plus sine theta equals to 0. All right, so what I'm going to do here is I'm going to divide. You just have to be a little creative here, but that's not the only way. I'm going to divide it by sine theta on all of them, on the whole entire equation basically. Okay, so cosine theta over sine theta is basically cotangent theta. Okay, plus 1 equals to 0. Now you know that in order to isolate the theta, you have to minus 1 on both sides. In order to save some space, I'm just going to put cosine theta equals to -1. Okay, color is bad, all right? Let me erase that, put -1. Okay, so cosine theta equals -1. We know that cotangent is x over y, right? So x over y, that basically tells you that you're going to get 1 in this quadrant 2, and another one in quadrant 4. Okay, so theta is going to equal to, this is 135 degrees, and then this one is 315 degrees. So you're going to put 3 pi over 4. Another one is 7 pi over 4. All right, 72. So this one, you can rewrite the tangent theta equals to 1 over tangent theta, because we know that the cotangent is just the reciprocal of tangent, right? So what I'm going to do is I'm going to multiply tangent theta on both sides. Okay, so that gives me tangent squared theta equals to 1. Now you know you need to square root both sides. And you're going to get tangent theta equals to positive 1. Okay, or you're going to get tangent theta equals to negative 1. Okay, we know that tangent is basically saying y over x, right? So you're going to get, for the positive, you're going to actually get it, the one in quadrant 1 and quadrant 3. Okay, the one in quadrant 1 is 45 degrees, so you're going to write pi over 4. Okay, the one in quadrant 3, you're going to write 5 pi over 4. Okay, let's look at the another one. The one with the negative 1, that's going to be in quadrant 2 and quadrant 4. So for the quadrant 2, you're going to write 3 pi over 4. For the quadrant 4, you're going to write 7 pi over 4. All of them are your answers.